me see, what is that? Thunderstorms. Yeah. Thunderstorms. Yeah, I actually believe this might have been... the thing had an eye-like feature. This thing was so close to becoming a super typhoon. My goodness. It was literally trying to pop off a rapid intensification. At the last moment, it just completely collapsed. Yeah, then expected to become a tropical storm again. But this thing literally tried to... I mean, look how weak it was. Just disorganized. I mean, you could see that low-level circulation under it, right? Look really closely, you could see that little LLC. And then look at that. Right around the center of the low pressure, look what happens. Boom. And then just a few hours before landfall, the convection weakens and it just explodes. And it forms a very well-defined center circulation. Casiguran. Probably wasn't too strong, probably 40, 50 mile an hour winds, but it was definitely intensifying. And then made landfall in northern Philippines on the island of Luzon. All right, let's go back to what we were discussing, which is Iwo Jima. Iwo Jima. There we go, Iwo Jima, and then let's go back to satellite imagery right now. Still going strong. Still actively erupting. You're looking right now, I would say, VEI of a 2, which is fairly weak, so it's weakly erupting right now. I mean, still throwing off explosions, but they're not high intensity. The reason for this is there's a lot of water in Iwo Jima because of all the rapid uplift. So it's still popping off like low intensity magmas. But what's going to happen is, I mean, you had just a stupid amount of uplift. Stupid, like, just stupendous amount of uplift since 1950s. Like, this island basically did not exist 1,000 years ago. And now it's almost, 400 feet high? All because of uplift? Just imagine the Minoan type eruption, but twice over. Or imagine this thing popping off maybe anything between 1 and 2 Tambora-sized eruptions. I mean, that's the worst case scenario, but a mid-case scenario would be something like a little bit bigger than Krakatoa. This volcano, Iwo Jima, it may hold off its attack until after our lifetimes, because this is not the first time Iwo Jima's erupted. I mean, you had magmatic eruptions in 2000 that formed a brief pyroclastic island, or tough ash from the Nijima event, even though that was not considered a magmatic eruption. But it was. But then the first confirmed magmatic eruption occurred in 2022. But that was not the first. I believe the first was in 2000. I believe that was a true volcanic, like a submarine eruption. But now you're definitely getting volcanic activity with new vents. The island, I don't think it's just going to escalate right into a caldera forming eruption. I believe it will continue erupting for a few more years and uplifting, and you'll get this back and forth, kind of, and then it will finally pop off. And I think the island might actually shrink a little bit, or even subside a little bit before its next CFE, because I believe it's hit critical mass. I mean, I think the magma chamber just cannot hold anymore. I think it's hit its absolute maximum capacity. I think this is as big as the island is going to get, because the island is bigger. I believe the island now is bigger than its last caldera-forming eruption. I believe that during its last caldera-forming eruption, the island was actually smaller. The entire caldera has risen above the rim of its previous caldera, both underwater and above land. And above water. Sorry. Above water. I mean, below and above water. Meaning that it's... And the fact that it's... I mean, it could still uplift more, but I believe the magma... Sorry, I believe that the magma chamber in Iwo Jima has hit critical mass. We've hit the point that there's just so much magma in the chamber that new vents are just popping off. I mean, you're not just going to have a caldera forming eruption, like go boom, because you have to destabilize the chamber first, and then all that pressure is going to get released. I mean, you're still going to have small eruptions here and there, but then as the eruptions get larger and you start depressurizing the chamber, that can trigger a runaway, which will then lead to larger eruptions and then would result in a climatic eruption. This is not like Pinatubo, where you would get like a blocking of the vent and it just will bleed in a climatic eruption like what happened in Pinatubo. This is different. This behaves more like a miniature supervolcano, as in like you have rim faults, because this is a caldera. This is not a supervolcano, but it behaves in a similar manner because of how large it is. This entire island is a giant resurgent dome. This is not a stratovolcano. It may have been at one point, but these are trachyte volcanoes, and trachyte volcanoes can pop off just as big of eruptions as rhyolite volcanoes, which is 7 and 8. Fukutoku Okanoba is one of those volcanoes, and it's located just south of that island, which is South Iwo Jima. It's actually very close. I believe South Iwo Jima is part of the same caldera, because South Iwo Jima and Fukutoku Okanoba are very close to each other, like a few miles, so it's part of the same caldera. Iwo Jima is not part of the Fukutoku Okanoba volcano. However, they are very close in proximity, meaning this volcano and the one right here, just south of that island, or part of that island even, produce caldera-forming eruptions. And I believe Iwo Jima is in the beginning stages of possibly producing bigger and bigger caldera-forming eruptions. This is due to back arc volcanism. Not true subduction, this is also back arc, where you get extra magma from subduction plus from weakness in the crust because of rifting due to subduction. This is not true rifting like where you're getting basalt. This is back arc volcanism. That's why you get trachyte and high alkali magmas, which have higher potassium, and alkali rich, just higher percentages of alkali and potassium, instead of true felsic volcanoes, which have higher silica and are more typical what you find in traditional subduction zones like in the Andes, where the name andesite comes from. The name andesite comes from named after the Andes Mountains, because that's the most rocks on the Andes are andesite, which is between 53 or 55 and 62% silica. Once you get above 62%, you enter the dacite territory. Most of the magmas at Iwo Jima are trachyandesite to trachyte, as trachyte means higher potassium. Usually, trachyte magmas are more commonly found in late-stage shield volcanism and back arc volcanism. Campi Flegrei is another example of a trachyte volcano, and is also likely in a form of back arc volcanism, but there's also slab rollback with the Adriatic plate subducting under the European plate. And the Adriatic plate is also part of the African plate, but I say it's Adriatic because it's like a segment of the African, or because it's like a kind of splits off instead of, it's kind of like a weird part of the African plate where instead of just subducting northward, it kind of forms like a weird kink. But I don't think it'll last that much longer, as the Adriatic plate is almost fully subducted, maybe a few tens of millions a year, like less than 10 million years, then it'll stop subducting. So, right now, during the day, during the day, you get to see that heat signature, and then when the sun sets, you don't see it anymore. There's two possibilities. One is at night, it's just something happens, and maybe you need the sun to see infrared, because maybe its satellite doesn't have its own, so it uses the sun to use infrared. And during the night, it doesn't work. Or a more interesting hypothesis is that it's erupting on a particular schedule where, it shuts off like a certain period and then restarts at a certain period. That's what I believe is happening, because, for instance, when the sunrise first occurred, the plume was very, very weak, now it's stronger, and it's day there now. I believe that it could be just how that volcano is working right now. You get pulses of volcanic activity which seem to coincide with day and night cycles. It's a little weird, but it's interesting. So this is looking at Iwo Jima's uplift chart. This is why I got so excited a few days ago. I mean, look at this right here. Yeah, look at that. Just insane uplift that occurred towards the very end. I mean, that's also pretty rapid. That's 2020. But now it got really rapid. Like, it shot straight up. In about a week, between August 31st and September 6th, let me show you the uplift, like how fast it's uplifting. I believe that's almost 17 meters a year. So once you do 30 centimeters, right? 30, divide that by 7, multiply that by the number of days. That's absolutely insane. This is, and then you divide that by 100 and you get your meter though. With Iwo Jima, it's been having about a meter a year. Let me check the satellite, or sorry, not Zoom, Google Earth. So, yeah, so let's do historical imagery. Yeah, they changed it right here. Still, they haven't updated it, but yeah. Look how much the coastline has changed. Just a few years. All of this is uplift. So the vents that are erupting is here. Somewhere in this area. And all these white patches could have been old vents too. Or uplifted corals. Definitely looks hydrothermally altered. Yep, hydrothermal alteration. And more hydrothermal alterations here. So, I mean, if it doesn't go CFE now, and then it calms back down and continues uplifting very soon, this island and this island will merge. I mean, I was expecting that to happen before the CFE, but maybe happening sooner than I expected. I mean, I expected a CFE like that, but the crazy thing is, right here. Actually, you see this? They built a road. Where's that road? The road. Yeah. That's a bike path. That's a road there. Let's go back to 2009, 2006. What do you see here? That's water. That is all water. And then, still water, right? 2024, boom, there's a road there and grass. And if you go back to 2005, you're in the middle of ocean. And you see how the coastline changed? See how it... Because it's very steep here. So you had some erosion here. Yeah, some erosion. Yeah, that's erosion. That's not subsidence. That's erosion. And then just kaboom, just blew up. Yeah, see how steep it is? That was definitely erosion. Unbelievable. Man, that magma chamber must be massive. If you guys think you get more hydrothermal alterations, even 2006, yeah, that patch is still there. But there was another patch of dead or dying vegetation, but I can't be staying up for too much longer. There was a patch I found. Unbelievable. You see that crater? Yeah, those are explosion craters from phreatic eruptions. It's a Mar. It's a Mar explosion crater. Look at that. See how it's drying up? That's because of groundwater from the ocean. That's salt water, groundwater. Just 3 years. My goodness. It did kind of roll back a little bit. See the sea kind of took back the land a little bit. There was a little bit of subsidence here and then just yeah, people walk here people are saying that this is like a minefield. If you're going to be here, eruptions happen. And now we're having an actual volcanic eruption around here somewhere. Geology Hub made a video on it. Okay, there, I think that might be one of those fumaroles. Yep. Or not, let me see. Let's go to 2006, right here. Look at that. Look at all this vegetation here. And look how that field. See right here, it's kind of green. And now it's like brownish. Yeah, that's an expanding hydrothermal area. Hydrothermal alterations right here. I think that was one of the areas I was talking about. And that's the peak. Ты будешь сидеть? Нет, иди, ты можешь идти обратно?
Нет, ты меня обманул. Ты вернулся, еще у меня такой телефон. А ты полтекса, полтора.
Okay, let's see. Some of these changes could be because of personnel activity, since this is also a military base. Right here. Yeah, like right here, I don't think that's hydrothermal. Could be, but see there's a truck here. Yeah, this is man-made activity here. It's man-made. You see how it just changes? Boom. That's man-made. This right here is... yeah, that's hydrothermal alterations there. But see, they're also building a road here. That's a road. I wouldn't do anything there. That's very dangerous. Alright, so... yeah, that's definitely hydrothermal. Let's go back to 2013. It's still there, okay. That could be hydrothermal, possibly. Runway's still in good condition. I don't know why it's not updating itself. I have to reset it again. Alright. I'm about to go to bed, but yeah, we got a vent erupting right here, right now.